Students, welcome to my channel. I hope everyone is doing good. Today we are going to solve a very recent and interesting array related coding problem. It's on Leetcode 3634, minimum removals to balance array. So this is a medium complexity, another popular coding problem and quite interesting problem to solve. So I thought that I would discuss this problem with you guys today, and I would uh, show you the logic as well as the solution to solve this coding problem. And I created a very nice example for you guys so that you can clearly understand this logic and this problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. Here we create videos to help others in their coding and Java interviews. So let's start. You are given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times the minimum element. You may remove any number of elements from nums without making it empty. Return the minimum number of elements to remove so that the remaining array is balanced. Note that an array of size 1 is considered balanced as its maximum and minimum are equal and the condition always holds true. Okay, so this is what the problem says. So let's glance the constraint. The constraint says that the array length is maximum 10 raised to 5 and the array elements will be between 1 to 10 raised to 9 inclusive, and k will be 1 to 10 raised to 5 inclusive. Okay, so the constraint here to understand is that the array is balanced if its values its maximum element should be at most k times minimum element, basically, right? So let's understand this problem better with some examples. So here they have given us this array 1629. So k is equal to 3. So they are saying that you have to remove 1 and 9. 1 and 9 you have to remove, then 6 and 2 is what you get, right? And 2 is minimum, 6 is maximum. So 2 multiplied by 3 is 6. So this is the basically minimum removal you have to make. So number of elements you removed are 2 here, because you removed 1, you removed 9, correct? And then you got 6 and 2 as your array, which is a balanced array, right? So here is another bigger example for you so that you can clearly understand this better. So in this case you have to remove the number 3 and you have to remove the number 16, right? Then these are the minimum number of removals and then your array will be balanced. So what is the condition here? K is 3. So it means that if you take a look at these numbers, the minimum number here is 4, right? So it means that your maximum number can be 4 multiplied by 3. K is 3, right? So your maximum number can be 12. So as you can see here, the maximum number is 12 here, right? And the minimum number is 4 here, right? So it means that this is a balanced array, because and this array become balanced after you only remove two numbers here, right? You only remove 3 and you only remove 16. So this is the minimum number of removals we have to do so that the array becomes balanced, right? So this is the example that we will discuss today. But how will we know that which numbers we want to remove, right? So for that, have you noticed that what we did, we removed the numbers 3 and then we removed the number 16, right? So it means that basically if we can sort this array, then we can solve this problem easily, right? So this is how we can sort this array, right? So after sorting, so this is the sorted array, what we can do is we will use a flavor, or we will use a flavor of sliding window algorithm here. But how will sliding window algorithm will help us here, right? So we can keep one left pointer here, right? Left pointer will be here and right pointer will move in right direction, and it will keep expanding the window basically. So how far it will keep expanding the window? Until the condition holds true. So what is the condition? The minimum and maximum element should follow the condition. So what is the condition? I'll show you one more time. Maximum element of the array should be at most k times minimum element. That is the condition, right? So now let's start with the sliding window. So let's say I have a window and I will also keep track of the maximum window size basically, right? Maximum window size, right? So because we are using a sliding window algorithm here, right? Okay, so right now it is 0 in the beginning. Now we are starting our window, right, from 3. So 3 we can consider, yes, then 4 we can consider in this window, yes, because it is following the constraint, right? The constraint will be followed until this point. Which point? It will be followed until 8, right? Until 8. Why it is not followed at 10? Because the minimum element here is 3, right? Minimum is 3 and 3 multiplied by k. So k is 3, correct? So maximum value you can have in the array is 9. So now when you go to 10, it means that it is breaking that rule basically, right? So our sliding window is valid until this point when it starts with this point. So do you agree with this or not, right? So this is a valid balanced array. So we will note its size. So its size is 5. So we will keep that track. Okay, we will keep the track. So let me just remove these things. So so far you understood this. So I will say my size is 5 now. So it means that I found out a maximum window size 5. What is that window size? This one, correct? This is my window size, which is valid, and it is uh, like it is following the condition. This is the condition. Maximum element is at most k times minimum element. Here minimum element is 3, maximum element is 8, because it's a sorted array, right? That is why we have sorted this array. Okay, so now it means that now the condition breaks when we try to expand this window here, right? Then the condition will break basically. So we cannot add 10 into our current window. Okay, so what we should do, we will move our window to this point. So now our window is like this basically, right? So this is our window now. So can I add 10? Yes. Why? Because your minimum is 4 now. Your minimum is 4, so your maximum can be 12. 4 multiplied by k, which is 12. So 10 is within the range, yes. So we can add 10. Yeah, we can add 12. Yes, we can add 12. So we can expand this window like this. So you are following this approach, right? Sliding window. Okay, so because 12 is possible, yes, it's possible, it's still following the rule. Now what is the length of this window? 6, right? 1 2 3 4 5 6. So I will keep track of the window. Maximum window size is 6, right? So that is good. So we have window size 3, window size 6 for this time. Can I add a 16? No, you cannot, because the maximum you can have is 12 here, because 4 multiplied by 3, right? 4 is your minimum number, so you cannot add 16 there. Okay, so what if I want to add 16? Then I have to move my left pointer forward. Where will I move my left pointer? My left pointer should go here, right? Then I can add 16. So this part you understood, right? Because 8 multiplied by 3 is 24 and 16 is less than or equal to 24. 5 I cannot add because 5 multiplied by 3 is 15. So 16 is more than that. So this window size will be 4. So what is the maximum window size that we have seen in this? So the maximum window size we have seen in this is 6. So you agree with this, right? This is the window size, this green color window, right? It is 6. Okay, so you understood this. So if we consider this window, so now I will remove everything, okay, because I explained you already. Okay, so now I removed everything, and the window that we found out, the maximum size is this window. I will highlight it for you. So this is the maximum balanced array, right? Maximum balanced array. So now if we consider, if our intention or our goal is to minimize the removal, so it means that this window size should be maximum for that. Do you agree or not? This window size should be maximum, then only you can do the minimum number of removals. Okay, so this is the maximum size window, and the removal that we have done is 3 and 16 from our array. So it means that we have removed 2 elements basically. So that's why answer is 2. So this is our approach to solve this problem. So I hope you understood this approach clearly with this example that I created for you guys. And the approach is that we take this nums array, we create a sorted array from this, we sort it out, and then once we sorted array, then we will start applying the sliding window algorithm here, and the window will keep expanding until that condition holds true. Whenever the condition becomes false, then what you have to do, you have to move your left pointer forward, right? Left pointer should go forward, correct? And this one is your right pointer, this is right pointer will go on the right side basically, right? To keep track of the window size, right? So we need 2 pointers basically to simulate the sliding window algorithm. Okay, so I hope this is very clear to you now, and let us go ahead. I'll explain you more with the Java code. So min removal is the method we are implementing. Nums array and k is given to us. First thing we'll do is the sorting of that array. Correct? Sorting of the array is the first thing. After that, we create couple of variables. N is the length of the array, max size is to keep track of the maximum window size, and left pointer is pointing to 0 basically, right? Index 0. Now, because we want left pointer and right pointer to keep track of the window, right? So here in this for loop, we are starting our right pointer from 0, and right pointer will go towards right. Okay, right pointer is moving towards right, and you will see that first we check here if nums of right is greater than k multiplied by nums of left. So we are checking if our condition is still valid or not, right? If the condition is not valid, it means that we have to move the left pointer forward because condition is violated. So we have to shrink that window basically. So it means that we will have to move the left pointer forward, right? So what I mean to say is, when you are starting, I'll explain you for the people who doesn't know sliding algorithm. So first you started your window from here, right? So everything was good until this point. Now everything was good. When you trying to when you are starting to add this 10 in this window, it broke the rule because your minimum is 3, maximum allowed possible value is 9. So you cannot add 10 into this window, correct? So now it means that, so what should I do? If I want to add the 10 into my window, then you have to move forward this left pointer, right? So that you can add that 10 into your window. So you have to move the left pointer forward basically, correct? So exactly what we are doing here. Okay, so this same thing basically. Okay, and at this time, at this point, we are keeping track of our maximum window size that we have seen so far. So how we will keep track? By using the maximum between your current max size and right minus left plus 1 will give you your current window size. So this way you will keep looping through this for loop until the end, and you will keep finding out all the balanced arrays and the maximum size you will find, right? Now at the end you have to just take number of elements in the array minus maximum size will give you the minimum numbers that you have to remove to make that array balance, correct. So here the total numbers are 8, 1 2 3 4 5 6 7 8, and sorry 8. So 8 is your total number, and your maximum window size that we have seen is 6, and that's how you will calculate how many number of removals you have to do. So you have to do total 2 removals, right? This and this. Okay, so that's what we have to return. So this is it basically. So I hope you understood this sliding window algorithm now, how it worked with respect to this example. Now is the time to analyze this algorithm. So for loop is order of n, but here the prominent factor is the sorting of the array, this one, right? So it takes more time. So let's write down that time complexity for this code is going to be n log of n, right? Where n is total numbers given in that array nums, and the space complexity for this code is going to be order of 1. This is also called as constant by many people. So because we did not use any data structure, no list, no hash map, hash set, or nothing, no other data structure to hold data basically, right? The variables, they don't count over space. So it means that this algorithm is said to be constant on space. Okay, so let's give it a run, make sure this code works correctly. And as you can see, the test cases are accepted. So this is the test case that I created to show you guys. This is my test case, and this is also working correctly, that we just saw, right? Okay, let's submit this code to the Leetcode now. Make sure the code gets accepted by the Leetcode. And as you can see, the code is successfully accepted by the Leetcode. It is 99.35% on the performance, which is an excellent solution to solve this coding problem. It's on Leetcode now. 3634 minimum removals to balance array. Another interesting problem that we have solved by using sliding window algorithm and with the help of sorting, right? So I hope you understood this problem clearly with this example that I created here for you guys. And If you like this example and this explanation, and if this example help you understand this problem in a easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is very valuable and important for us. It really helps and supports this channel. It takes lots of efforts to create these videos, to come up with these examples and to explain these examples so that others can easily understand and follow. So if you want to appreciate these efforts and be little generous, then do give it a like for this video, subscribe to our channel, click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their coding and Java interviews. More than 550 solved coding problems are here for you to help you out in your learning as well as in your interview preparation. The important playlists that you should visit are graphs, matrices, binary search trees, binary trees, different data structures related playlists such as stacks, queues, priority queues, min heap, max heap, problems related to dynamic programming, memoization, recursion, how to use and apply BFS and DFS on graphs, matrices and trees. So don't forget to check out those important problems. Those are important coding interview questions that we have explained just like this one by using whiteboarding sessions so that others can easily understand and follow the approach. So keep learning, keep coding, keep solving more varieties of coding problems, and thanks for watching this video and have a great day ahead.